right, welcome to Manson's Math Lab. Thank you for subscribing to my channel. I want to cover this example from the topic of real analysis, the Weierstrass M test. So I have a sequence of functions. I've called them f. Now their independent variables can be x if you like. It's defined on a metric space E. So the independent variables live in my space E. Typically these are real numbers, right? Well, for our purposes in this example. And let me just write down briefly what is the M test. So for this sequence of functions, we want to say something about the convergence of the series actually corresponding to this sequence. So suppose we have the following situation, that the absolute value of each term in my sequence of functions is bounded by some, what we're going to use as m well, let's use actually, yeah, let's use n. Let's use n for x in whatever my underlying space is. Here I called it E, and n in n. And by the way, we may have that this inequality is not true for a finite number of values, but as long as it's an infinite number of values, we're good to go. Okay? Then, here's the conclusion. The conclusion is quite nice. Then, the series, actually, Fn, converges uniformly if the series of the m's converge just regularly. So the m's do not play, well, they do not depend on x. So if I take a series where the summand are these m sub n, so if I add all those up to infinity and they converge, then I know that my sequence of functions will converge. This intuitively, I think, makes sense because we're taking something which is larger, adding them all up, saying it converges. That means something that's smaller than it must also converge. So intuitively, I think that makes sense. Now let's look at an example of this. Okay? All right. Here is the example I have for you. So I want to determine if the series converges uniformly. Man, all right, here's the series. So we have the sum from k equals 1 to infinity. I use k, whatever, of sine of kx divided by the square root of k to the fourth plus k squared. So, idea here is I just want to bound the summand, right? So if this is playing the role, we can think of these as my sequence of f n's, and if you like, we'll put a k since these depend on k. I use k instead of n, doesn't matter, it's just labeling, right? Doesn't matter. All right, I want to bound these. Right? I want to use the theorem. I want to use the M test. So we see, notice that I have this business, right? I have that the absolute value, well, let me say this actually. This is how you really convince yourself, okay? Absolute value of sine of kx is absolutely less than 1. I mean, the range of sine is -1 to 1. Take absolute value, it can't be any greater than 1. Divide everything by this. All right, then this implies this is a positive number. If I divide both sides of an inequality by a positive number, I keep the inequality remaining the same. So this is absolute value sine kx divided by square root k to the fourth plus k squared is less than or equal to 1 over the square root k to the fourth plus k squared. This looks good. This looks good. But what do you want to say about this? What about this guy? This is less than or equal to 1 over the square root of k to the fourth, which equals 1 over k squared. Now back up a minute. Is this even true? Take a step back, be patient, say to yourself, hell yes, this is true. What did I do? I canceled out the k squared. Why can I do that? Think about it for a second. Let me give you a second. 1 Mississippi. All right. What's the difference between these two? This one, the denominator in this expression is larger than this one. It's at least as small. So what I mean here is k is taking the values of 1, 2, 3, 4, etc. So actually, this value, this expression is always smaller than this because the denominator is larger. If the denominator is larger, the number is smaller. So this number has a smaller denominator, so it's larger than this one. Convinced? Good. What do I know about this? This is P series. This is, let's say this is convergent P series. P equals 2. Let me write down my conclusion because I'm done. I'm all good to go. I'm all good to go. So conclusion. The sum from k equals 1 to infinity of 1 over k squared converges. So what can I say then? So, hence, by, I'm not going to butcher Weierstrass's name, by the M test, we know that k equals 1 to infinity of sine of kx over square root k to the fourth plus k squared converges uniformly. That's it. Hope it makes sense. I think it's relatively straightforward. Tell me what you think.